Good morning, everyone. Um, Today is the second day of the workshop. Welcome back, and we'll start off um, with a continuation of the R. And in the second half of the day, there will be an SQL session. So we will continue in the materials from the manipulating data tab and see how we do subsetting using the more modern type of tidyverse approach, and then look into plotting data. So let's wait for a couple more minutes for people to join. And meanwhile, make sure you have loaded your data set back in so it is in your environment and you can view it either by clicking on this little symbol or by calling the view function with the data frame as an argument.
Also load in your
Well,
libraries
good
if you haven't done
afternoon.
that
Yeah.
either, right?
Some people connecting from Dubai. Yes, so you might need to also load the library tidyverse package. Loaded, nothing will happen. If it loads for the first time, you will see it will report on what has been loaded. So we can put the structure of our data set. We've got some factors and some columns are not yet factors. We might need to convert them to factors. So remind yourself also how to do that. We're just about to start.
Evgeny, I'm wondering if it's worth putting into the chat which variables should be factors, just so that people are aware and they can look back on it.
We'll see. Once we do the ggplot steps, we will see some artifacts in the graphs if they are not factors, and then we'll correct those.
Cool.
But for instance, for me, for example, as we did yesterday, taxa is already a factor, and genus column is also already a factor. So as a reminder, factors are used in R specifically to describe categorical variables, features that have levels, so different possible values that they can take. And this will be useful to group on those later on. Okay, welcome back, everyone. We'll continue where we left off yesterday, and we will look now into the tidyverse way of selecting columns, filtering by rows, adding new columns, and then we will look briefly at grouping and summarizing data, as well as briefly look at scattering and gathering data, which means changing it from long to wide format and back. And finally, we will learn how to export to CSV, and then move on to visualization. So overall, tidyverse has historically developed as a kind of set of best practices and then commonly used well-defined functions that kind of integrate well together to accomplish common data manipulation and reshaping tasks. So yesterday we have seen the base R way to do things. So if you haven't got the surveys loaded, I'll paste it in. You can use the read CSV function to do that. And we can use the dataset, the raw dataset, and we will set the factors later on. Okay, let's have a look at the structure of our data. So we can use the str function. And so for me, the data is already in the environment, so it shows up. It has several observations, and the structure output shows what types of columns I've got and what some summary of the values that there are. So we can also use the view function to view the data in a separate tab. It's also like only few rows are printed here, not the full data set. So this way we can ensure the reading in has worked, and now we're ready to work with the data. So let's start by selecting some columns. Okay, let's have a quick check here whether everyone has got the data in the environment. It shows up and you can view it in it. We can check with dim the dimensions of the data set, and it should have as many rows and 13 columns. We can check the column names. It represents the features of our data. And then if we wanted to select, so once we have loaded the tidyverse library, those functions will become available. We can use tidyverse dplyr way. So one package included in tidyverse called dplyr, which is for data manipulation. If you need a reminder how to set something to a factor, Toby has posted it into the chat window. And this dplyr package defines several verbs or functions that can be used together to achieve desired result. One of them is called select. It can be used to select some columns from dataset. For instance, use plot ID. And let's say species ID. And wait. So we can see we've got a result that has 3 columns. And it's a table that's a data frame like table structure, an R object that has some other features that data frames might not have, but it's not relevant for us now. But we see we've got an R object with 3 columns. That's what we wanted. If we want to select everything but a particular column, we can use a minus sign in front of the column name when selecting, and then this will be dropped. So if we want almost all columns, but we want to exclude, let's say, record ID, then we type the minus here and we get the original data set except for the record ID part. At the moment, the resulting new data frame is not being stored. So if we wanted to store it, we would need to assign it to a variable. So now we can also use filters. So filter is another way. This is a way to kind of filter out data by some condition, let's say. So we can subset our data set and select only rows, the observations that, if you remember, the tidy data principles. One of them is that we have one observation per row. So this way we can filter and select a subset of rows. From surveys, for example, if we wanted everything with weight smaller than 5, we will receive another table here. So I hope this makes sense so far. So we've got different functions that take the data and then either the names of columns to select or the condition that is used to filter the rows. So you can think of select as a kind of shortcut for doing what we did yesterday to select a column, but then we can select multiple columns in one function call. So it goes for each of those, it selects it, or it selects all but excludes some. So there is some complicated logic hidden inside the select function, but that's the nice thing about using packages, that we don't need to write it ourselves. We can reuse existing functions. So the problem here that arises is that what if we want to do the select and the filter both? So and then let's say if we decide to save it, the result of filtering, we already use surveys, so let's call it filtered. So now if we run this, we will see we've got a new data set appear here, which is a subset of the original one. Now if we want to select something from that and save it, then again we would go ahead and find another variable name, and you can see how this becomes quite unwieldy once we've got more and more steps in our data analysis pipeline. It also kind of convolutes our environment. Now we kind of duplicated a data set in memory, and if it's very large, this might become. So this is a mistake, by the way. So beware of copy pasting. We want to apply our selection to the result of filtering. So if we rerun this, we've got an even smaller data set here. So someone might come up with a suggestion what we could do here. So let's say if we're not using the filtered data set anywhere, we could do something like nesting. So we could instead of using a separate variable, we could do the filtering in place. So the data set that is returned will not have a name by which we can refer to it, but the result of it will be immediately passed into the select function as argument here. And this way we can still get the same results. But now we've got, let's type again. So now the problem is that we cannot easily read it from left to right. Now we need to read the whole expression from inside out. And this will become also quite tedious once we've got a deeper nested pipeline. So it might work for some examples, but Tidyverse defines a better way to do this using pipes. So it is a symbol with % sign and two percentage signs encompassing a right arrow. This is the same as the symbol we used for relational operations, but now it's enclosed in the percentage signs. You can get this symbol by typing Control-Shift-M or Command-Shift-M for Mac. This is called a pipe, and it comes from a grid-R package. It's a the head to a famous painting there. But how the pipes are used, they connect different stages of our pipeline. So now we can do something as follows. We can start with our data. Then we use a pipe. So we pipe it into the next stage of the pipeline. And because the tidyverse functions working well together, they all produce some data that can be further piped down the pipeline. So we use the next pipe symbol here to pipe it into the next pipeline stage. And this makes it easier to read and to write. So we can now read this pipeline as take the survey data, filter out all records that have weight smaller than 5, and then select specific columns. So let's select something else here. So for example, species ID. Second weight. So now if we run this pipeline, if we place the cursor at the back of the line and hit Control Enter, then we'll have the results. Still, this will be produced and it will be printed here, but it's not saved anywhere. So we would need to assign it to a variable. As we did before. So the common way to write it is like this. And then the result of the whole pipeline will end up in service small. And we can have a look. Yeah, there's some results. One missing value, but that was there before, I guess. And this is a nice way to kind of zoom in onto part of the data set that's we're interested in and do some exploration. Okay, let's do a quick exercise. The exercises. Okay, let's copy. We'll copy it also in the shared. Okay, what we want to do is subset the service data set Include animals data collected before 95, and the columns should be year, sex, and weight. Let's spend a few minutes on that. You might need to refresh your browser window to connect to the Etherpad again. We're around line 150 in that document. Feel free to post any solutions, suggestions there. Whoever's still trying it, don't look at the chat if you don't want spoilers, but there's been a suggestion that looks good to me. So one thing about the pipes is that you might think it might look better if you have a pipe in the front of the line. But it will not work because of the way how it's how it's defined. So it needs to be at the end of the line. Here, let's see what happens here. Yeah, it still doesn't like it. So yeah. If you see an error like this, probably there's somewhere a stray pipe symbol on the beginning of the line.
If I can add in something as well, sometimes if you can add a pipe, and then when you press enter, it should then indent. So you can see that filter and select are indented from surveys. But very rarely, sometimes you will press enter and it won't indent. And then it's not worked. You're better off just deleting the pipe, doing it again, and then pressing enter. And sometimes if it's not indented, it won't recognize the filter either. It's just another thing that I've observed.
Cheers. Okay, we've got a solution candidate. Let's see. So we need to take the service data set. We can use tab completion to save us some typing and making mistakes. So then pipe it into filter. And then have a condition that specifies that year must be less than 1995. Maybe some of you went to select first, and I think in this case it doesn't matter which stage you go through first in the pipeline. So we'll get some result. Look as expected. So, but of course there is not a single way to do this, so you might have come up with a different way. All right. Are there any questions about selecting and filtering of the pipes? If not, let's move on to see some other functionality offered by dplyr from tidyverse. Another function we can use is mutate. So this callout already gives us some idea what it does. So we can preserve existing variables, but add new variables to the dataset. This amounts to adding new columns based on existing ones. So for instance, if we didn't have yet the weight in kilograms, we could calculate it using Mutate and then assign the result back to surveys if we want to save it, but I'll leave it as this. So we need to create a mutate stage in the pipeline. Do tab complete. Weight kilograms. We give a name to a new column, and then we can define it, for example, in terms of existing columns. Weight divided by 1,000. So this would give us a new date frame with 14. What we can do is also pipe things to view. If you want to quickly double check what we've got. So we can see we've got a new column, and where values were not missing, they now got a new value. And then this is called dot here. This is like this data frame that was just created. But it will be thrown away after this line because we didn't save it. But that's fine. So what else we can do is we can add multiple columns in the same mutate stage. So if we wanted to have also the weight in pounds, we can also here already use the previously defined one in the calculation. That's quite nice. So we don't need to first save it and then use it again. So this it's a bit annoying to have the NAs there, which are special values are used to represent missing data. So we can first filter out all observations with missing data by adding another stage to the pipeline. And this way you can see we can iteratively build our pipelines gradually until we've got the full pipeline we need. We can use isNA function, that's predefined function that will return true if something is NA. And what we need is everything that is not NA, so we can place this exclamation mark representing not in front of it. And here we need to provide column name. Okay, this way we can see we don't have any NAs in the based on weight. There might still be some missing data somewhere else. Any questions about Mutate? If not, let's do a quick exercise for Mutate. I'll paste it here and in the shared doc as well. So we need to create a new data frame that meets the following criteria. It contains only species ID column and a new column called hind foot centimeter, which itself based on hind foot length, so it converted to centimeters. And there must be no NAs in that column. And additionally, all values should be less than 3. Okay, let's compare the number of rows as well that we get out of this. Think about the order of in which you arrange your pipeline stages. Suggestions, feel free to post them. I'd prefer if they go into the shared doc rather than into the chat. But the number of rows could go in the chat here. So to approach this, we would start from the survey's data and pipe it through the stages. Then we can think about what should the stages be. So what we can also do is to pipe things into regular R functions that take some data as an input. So we could, for example, use head here. Okay, we've got a few suggestions with different order. Could you also paste the number of rows you have? So we could start from top to bottom in our criteria, but then we'll realize if we drop every column except species ID, we will also lose the hindfoot length value. So we would need to create hindfoot centimeters first. But then there's also should be no NAs there. How would NAs come into that? It's if the original column, the hindfoot length, has NAs. So we could start by filtering out NAs from the original data set. Then we could create our new column. Or perhaps we could select first. So here it's not crucial in which order we do. Sometimes it's so one pipeline might run a bit faster because filtering happens before other operations. So filter before mutate is often a good idea because it will reduce the data set size before. So let's create the hindfoot centimeters from length. And the original length is millimeters. So then we can filter out based on the value. So the new column should be smaller than 3. And then we wanted to keep only only 2 columns. So we need to select as well somewhere. So missing the pipe symbol here. Oh, there's something wrong with my pipeline. Let's see. So what we can do to debug a pipeline, we can comment out different parts of it. So we could check, is this stage working? No, so we found that there is an issue here. So it could not find the function isNA. If we look up here, it should be a dot. So we can put it back in. Now we can check this stage is working. Then we can move on and uncomment the next stage. And this is how we can diagnose issues in our pipeline as well, and so on. So once we're confident we've got the error fixed, we can go back to pipeline. And it's a good way to check intermediate results originally. So we've got 2 columns. Oh, interesting. So now I've got only 6 values here. Some people were getting thousands. Let's see. Can you see any issues with what I did? Okay, that's a bit of a trick question, I guess, because head gives us 6 values only. So I would need to pipe it to something else to check the actual number of the result. So as you can see, we agree on the thousands here. Instead of piping it further, we could save it and then check that later. It's a bit of a too cryptic name perhaps, but let's go with the short notation. Usually we would choose something more meaningful or more easy to read, but as this is a quick example, I'll leave it at that. All right. Let's briefly talk about grouping and summarizing. So often we will need to think about different groupings in our data that we want to compare. And the idea behind this kind of split, apply, combine approach. So we split our data based on group, apply some functions or pipelines to the different subsets of our data, and then combine back the results. And it can get quite complicated in reality if you've got, for example, an ensemble study, and for each ensemble you have a data set that you need to group and so on. But as an example, we'll stick to non-nested grouping here. But the principle applies to also more complex data sets. So there are some papers you can find if you search for split, apply, combine. So for instance, we can group by our survey data using a pipeline. And group by is a method, is a function provided. Oh, sorry. Group by is provided by dplyr as well. So we can provide a column name, let's say sex in this case, group by this. So the dataset will be split based on the value of that column. And then we can summarize. And we can create a new column here for the summary. We want to look at mean weights. And then there's a way to exclude missing values. So we can set the argument NARM to true. I will pipe that to view. So we can see. So what does it mean? There are some missing values. We don't know exactly, but some animals must have escaped before it could be determined which sex they have. But the rest is roughly similar. So it seems like mean weight is helpful in escape which might be counterintuitive. So it's also possible to group by multiple columns. So if we want to further specialize the output, species ID, let's take species ID. So now we can see we can get values breakdown both by sex and by species ID, which is quite handy. And an ARM means if we've got an NA, which is representing a missing value in R, then this observation will not be considered. But NA is a special value in R. So we can remove those not in the data set itself, but for the purposes of the calculation. So the mean function takes values from the weight column, but then it can also drop the NAs. So otherwise it might return something called not a number, and this will make calculations more tricky in the other step. So it disregards them in the sense that if we've got, let's see, mean of 2 NA, so you can see that in that case we would get an NA. If NA is present, then in the initial case, mean would also give us NA. Because it's not a numerical value, so it cannot be used in the calculation. So we need this NARM set to true. Does this answer the question? So summarize. Let's have a look at the result again. What will summarize do? There's a question. Summarize will take a grouped set of, so this is the apply stage. Group is like the split stage. We have now groups made from our data set, and summarize will, for each group, perform some calculations. So mean weight here corresponds to the new column in the result. And the right-hand side determines how the calculation is performed or what type of analysis is done on the values. So in a way, what group does is we gather together all observations that have same values for the specified columns for group by, and then we take all the values and use them in our calculation. So this way we can have a more detailed summary by grouped by, we could also group by year, for example, then we could have like different groups by year, and then we can plot those. Okay. It's also possible to have multiple columns in the summarized part. So if we want to, let's say, also minimum weight, we might add min weight equals min weight, like so. And we would see NAs again if we don't drop them. And we will be warned if some NAs are dropped, depending on the function we use. But the main thing to see here is we can combine multiple values. So maybe we want quantiles and so on. So we can choose our statistical kind of methods and functions, and then. So let's leave the NA part in. And then we can also arrange things. This means we can order the output. So it's by default ordered in ascending order. So we can order it and we could see in increasing order of weight, min weight, we're going up. We can use desc if we want to go the other way around. So for descending order, we can apply function to the variable along which we arrange. If you got any errors, it's useful if you post the chunk of code you're running at this as well. So it might be that there's some issue with formatting, or maybe a parenthesis is missing somewhere. Is this survey data set in your global environment and it contains some observations? So maybe there is a parenthesis missing after true, yeah. So one common way to summarize things is to use a count function. So that's like a shortcut for group by something and summarize by counting things. So we can use count to do that. So this way we can quickly get an overview for some columns. For instance, are there missing values and how many are those? If we wanted to, we could use the convenience argument sort. Sort it in descending order. So to achieve the previous step, we could count species ID, I think, like this. And this would get the values. Okay, let's do an exercise. Okay, the question is, what was the heaviest animal measured in each year? Include columns year, genus, species ID, and weight in the output data set. If you've got any suggestions, feel free to drop them in. We're around line 240 in the shared doc. Any suggestions? So think about that. We also might want to drop NAs from some columns. Okay, so again, we start with our service data set, and then we will need a couple of stages. So we could think about like pre-processing data. Because we've got NA values, we might want to filter them out. And we can first kind of in words define our algorithm. First, we want to filter out NAs. Then, because we want to measure in each year, we want to group by year. And then so then it's a question mark. We need to look into detail how to do it. And in the end, we want to select only a few columns that are specified. And because select is already so close to how we would write it in a language, or we can write it in code straight away. Did it say species ID? Yeah. Any suggestions so far? So filtering out NAs, helpful for ongoing calculation. It's like a data preparation step. Not is NA, because we're looking at weight, we'll drop all the missing observations. Group by year. So that translates fairly straightforwardly into the deploy syntax. Then we can replace by pipe. So next we will then move into main stage. Okay, there's a neat suggestion there. Let's see if it works. So what's the maximum weight you're getting when you run your code? And at each stage we can examine the data we've got. So group data frame will look different. So you can see it's like a list or some more complex objects. So it has 26 groupings in it. So it's still based on our data, but it has something called groups in it. So that's an indicator that group by was applied to our data set. So once it's grouped by, we can summarize it, or we can mutate it. I'll try something else. Okay, I've got something that resembles by year output. It's quite difficult to see what the max is. How could I improve my pipeline here? So at the moment, the problem is the weight that comes through. They're not sorted at all. Where exactly would I add sort? So some functions have sort built as a built argument, but first, yeah, so sorting is a good call, but the way we do sort in the canonical way is to use a range. And we can decide how to arrange it. So if we wanted to heaviest ever animal, we'd find it this way. But maybe we want actually to look how the change looks like going from year to year. And it's up to us. So there are different ways to sort. So that's one of them. Let's have a quick look at some other suggestions. Okay, that's interesting. Let me copy this. So if we look at this, so it looks like sort might not be, or maybe true should be this true. Let's see. So we've got something, but is it what we wanted to have? That's the question. So first of all, we can see NAs are still there. And what count does, it counts the number of observations for that year. So from this display, we know so for instance, how many NA weights are there in 77? But that might not be exactly what we want to see. So for this exercise, I'd go with filtering and grouping. But if you wanted only like the heaviest ever animal, you could do it in the similar way with summarize. So you could group by year and then summarize by max weight and then sort or arrange. So there is an error in the chat that is object year is not found. So this is suggesting that maybe you have selected something, but you didn't select year to be included, or you grouped by something other than year. Okay. Yeah, I think we're running out of time for this subsection. So I'll briefly mention one section we'll leave out today, but often data might be structured in a wide format where some values, so if we think of some values as keys in a database, then they might then in a wide format table be inside the cells themselves. And what would have been a key in the long format becomes kind of column headers for this wide format. And there are ways to reshape data back into the long format that is nice for plotting. So in manipulating data material, there is a section on reshaping with gather and spread. I'm not going into that now, but I encourage you to have a look at that so we can get to plotting kind of homework. So there is also some explanation how exactly long and wide formats look like. Let's have a look quickly how we save our data to a file. So to export to CSV data, let's first kind of create something we could call like a complete survey. So surveys that only have they have no missing values, with observation with no missing values, at least for weight, hindfoot length, and sex columns. We can do this by creating a new data frame, which results from running our original data through a pipeline using a filter stage. And here we can see we can have multiple conditions in the same filter. We use the column names for which we know there are some missing values there. Right, we've got a new data set. So let's see. And let's assume we want to have look at the most common species. So as a quick exercise, extract most common species. So with more than 50 observations. So if you want to use the count function, it already does the grouping based on its argument. So there's no need to do group by and then count on this using the same column name. So we're in around line 260 in the shared document. And we can keep it by arranging it to the same. Keep it by arranging it. So by assigning it to the same service complete data set. But first, let's get the species counts. The idea is that we can then use that count in a condition to filter. So let's use species ID. as a criterion, as an argument for count. This will give us some counts. We can see. Yeah, some are fairly infrequent, so we don't want to include those in our final data set. So we can drop them filtering. But we need then to also filter our original data set later. So first we're creating a set of species IDs for most common species, and then we can compare those to those in our original data set to drop all others. That makes sense? So I'm updating the species count. And I will also be updating the dataset I want to eventually write out as a CSV file. That's why I'm using the same name on the right-hand side here as input filter stage. Oops. Control Z will undo the previous step if something looks odd, if you broke your code in some way. Sometimes the wrong tab complete might create a bit of chaos. And now we can use this in operator we have seen before. So we want only to include species IDs that correspond to the IDs from our that we have counted before and found that they have more than 50 or equal to 50. And here we use the dollar notation to select column as vector from a data frame. Let's check how many records we have left. Yes, I should have mentioned that. So the N is something count creates. So if you think of count as a shortcut for group by, whatever the argument is, and summarize, N equals count. Okay. Are there any other suggestions? So you might have come up with a different way. To do this, that's also fine. If not, I'll copy this because we'll plot this data later, like in the next step. So I'll copy paste this into the shared document. So we should have 30,400 63 observations in the service complete dataset, and now we can finally export it by using write CSV function with an underscore, not a dot. And it takes the data, service complete, as an argument, as the first argument, and as the second, specify where to put that file. So let's put it under data. If we run this, it should appear in the data folder. And we could read it in using read CSV. So this way, we have completed the run through the tidyverse verbs. Not all of them, of course, but the most commonly used ones, such as select, filter, arrange, group by, summarize, and mutate. So we can select different subsets of our data, we can group it, and we can summarize it in different ways and save the results for later analysis or for visualization. Are there any questions about those parts? Let's spend a few more minutes to catch up and have a short break. If you're finished, feel free to walk about and stretch a bit. So we'll continue with visualization from 11. And there's a question about the CSV part. So .csv, that might be the original base R writing function, and it's not designed to work as nicely together with the data structures and functions in tidyverse universe. But write CSV function with the underscore that comes from read R package, which is part of tidyverse and works nicely together with tables and so whatever comes as a result of applying different dplyr functions. And it might also be faster because a lot of the tidyverse code is actually optimized. So it's the core of those functions might be actually written in C++, and then R calls the compiled code, which runs much faster than it would be to interpret R commands directly. So yeah, I think in the older scripts, you might still see the old way of subsetting using square brackets and dollar notations. And then in more recently written scripts, I think tidyverse is becoming the standard way of writing such kind of pipelines. All right. Hope everyone had a nice break. And that everyone got that service complete CSV file. or maybe it's still in the environment as well. So we will be using that data set for visualization. For that, we will be using ggplot2, which is also a package as part of the tidyverse set of packages. So if you have imported tidyverse, then ggplot2 should be around, so we can check. The library itself is called ggplot2, but the function we'll use is ggplot. Then we can see it's available, so we can. First of all, we need the data, and we can read in the CSV from the data subdirectory, or we can reuse the data frame that we already got in the environment. Oh, strange. Let me see. For some reason, the sharing has stopped. Let me share again. Okay, can you see it now? Probably my screen went into like sleeping mode. Great. Sorry for that. Okay, so now we can check the survey is complete, has the correct size. So it should be this number. And so in this part of the workshop, we'll learn how to use ggplot to plot box plots, time series plots, and scatter plots to set universal plot setting and then customize the plots to use different title, different axis labels, and also to look at faceting, so to have kind of groups of plots grouped together. And this should be plenty of material to get us to lunch. So after importing the data and tidyverse library, we can use the ggplot function. It implements something called a grammar of graphics. I will not go into detail explaining all the components, but the idea is that graphics can be defined through different layers of different elements. So the data defines the values, then different aesthetics can be defined. Those would be the axis, the x-axis, the y-axis, different tick marks, and then different geometrical functions can plot the values eventually in that space. So I encourage you to look up grammar of graphics. There is also a paper by Hadley Wickham, who is the main creator of the ggplot library, who describes how he implements it. So let me first paste here as a comment the overall syntax of using ggplot. So these are the layers. So the ggplot takes a data argument. Then we define the mapping, and we'll see how those look like in a second. And then we can use a plus in the same way we used the pipe symbol to add different layers of geometrical representations to the figure. So let's give it a go. If we use our service complete data here, cannot see anything yet, but in the plot pane, there is kind of a gray square which defines the area of the plot. So the first layer is only making the connection to the data set. It didn't yet add any further elements to the plot. And everything that goes in brackets here, for the ggplot function, these are the so-called universal plot elements or settings. So the statics mapping can be defined as, so it's used to assign variables to the axis. So x, what we're going to plot, let's say weight against hindfoot length. And use that. So we can see now, instead of our gray square, we already got the tick marks and the axis set up. By default, we see a grayish background, which makes it a little bit easier on the eye if we look at the screen representations of the figure and click on zoom here to kind of have a larger plot in a separate window. Okay, let's see, there's a question. Oh, interesting, there's some more involved looking issue there. Maybe one of the helpers can have a look at that. Cheers. So now we've got kind of our background for the plot set up. What's missing is to put the geometrical representations there, and we can do that by adding that with a plus. However, if we try to add the plus on the new line, this will not work for us. For the same reason, it didn't work with the pipe symbol. So we need the plus to be on the previous line, like at the end of the previous line. And then if we use geom point, it will use the point representation for our data. We'll get a scattered plot. The title is still missing, but we'll get to that in the end. So now we can see each observation is represented here as a point on this figure. Some quite dense areas, so it's difficult to see. So there's some overplotting happening there. So what happens here is ggplot call produces a plot object that can be then used. And then by applying the plus and using the geom function, we can use it. We can add a layer to that plot. So it's possible to save that object and use it later on. So we could do something like this. And now my plot is a GG object. So which is a GG stands for grammar of graphics. And now if we add a geom to that, there are many different geoms, as you can see. We will only look at a few in the workshop, in particular points. So having, We can also have an aesthetic settings within points that specifies some details of that specific layer. We'll look at this in a moment. So, but now when we add to the object, a replotting happens automatically. So it takes a while for me, quite a few points. And here in this view, we can go back and forth between previous plots that we had. And we can delete those if we don't need them by clicking that X button on the right. So for instance, one aesthetic setting, or one setting of the points rather, is the alpha value. So this is, we can make the points slightly transparent to some extent avoid the overplotting effect. And we can see that once the figure is produced, some areas are more dense where more dots overlap. If we zoom in, we could see that some areas that looked quite densely black before, actually there's not as many points as in other areas. So we can vary this value. One would be completely non-transparent. We can add a color as well. So for instance, type color equals blue and replot. The color of the dots will change to blue. What we can also do is to group it automatically. So when the color is used in conjunction with the column name, then the data will be automatically grouped. So now species. Now we should get a different color for different species ID in the output. And that's quite nice. This way we get some kind of visual representation of clustering in the dataset by species ID. So we can see some species vary widely in their weight, others less so, and others vary both in height and weight quite a lot compared to others. So it's still quite some overplotting happening, and we get some bands because the length is all integer values. But we could use jitter, for example, to change slightly the position of the dots. Oh, interesting. If species ID is not found, it might be missing in the data set, or it might not be a factor. You could try, if it is, okay, let's see. So in the complete survey data set, might need to be a factor. So we can turn it into a factor in a similar way as we did for genus or taxa in the past. So something like surveys complete. Let me see. Species ID. If you've got the CSV file, you could try reading it again with read CSV, read underscore CSV, to restore it. Otherwise, you could try this, set it to make it a factor. We need to kind of take it and convert it to factor by applying a factor function to it, and then assign it back to the original column. This facilitates the group by that is happening in the behind the scenes. Okay, if it's a character, I'll copy this into the shared document as an example of how to switch to factor. It should turn into factor and then this should work. Let's see. Yeah, don't worry about the colors for now. We'll come back to customization in a moment. Let's have a look first at a couple of other geom types. So it's possible to use so-called themes to we can use themes later on to change kind of the color settings of the figures. Okay. Um, so could someone of the helpers create a breakout room for that? So let's yeah, so if you're recovering from the very original CSV, then you need also the step of dropping the values which have NAs in them. But we can work around those as well in the example. Okay, let's have a look at another geom. So perhaps we can do this as an exercise. So so try use geombox plot. And meanwhile, we can also try to sort any issues still remaining with the data set geom. Okay, so let's have the task visualize distribution of weight within each species. So we can group again by species ID. Also on line 286, could we have a quick poll in the shared document if there are any issues still remaining with the data set? If you could put an X in for yes or no, see if there's anything still missing there. Okay, it looks like there's still some issues. So we can start from the very original file rather than loading the service complete CSV. We can start with the original data file and create service complete from that. Yes, so please use the shared doc. The code formatting goes kind of is broken if you paste it into the chat here sometimes. So. Okay. For that, also check that there is a service complete CSV in your data directory. If it's not there, then the read stage will fail. If it's not there, you could still use the data raw data, load that, and turn the column you want into factor and use that for plotting. I think this should still work. If you have species instead of species ID, you could plot that. It will probably look the same in the output. Only that there will be then a name rather than the code. Okay. Hopefully you got the species IDs back. Because we're going to need it now. So ggplot, specify the data next. I'll still stick with the surveys complete, but you can work with the surveys themselves. And you don't have to choose the same. If one column is missing, you could try plot a different column. But I'm gonna stick with species ID for now. But I'll use boxplot this time around. So if we zoom in, it looks a bit convoluted, but now it looks a bit more readable. So we've got, at least we can see the mean values, whether they differ or are kind of similar. So we can have a slightly better idea about distribution and the number of measurements this way. But we don't see the dots themselves easily because they're all presented on the same line. So what we can do is first to make the box transparent. This will remove the background. And then we can add jitter. There's another geom called jitter that places the points in a range. So it moves them a little bit so they're not all plotted on top of each other. And it can also take alpha setting, then the color. So now we can see the dots completely overplotting the boxes. What can we do to change that? To have the boxes on top. Any suggestions? So yeah, programming is kind of empirical, and the nice thing about having code is that you can save it in a script and somewhere in a version control, so you can break things and then not be afraid of losing your code, so you can go back to the working version, so we can experiment. So as geoms are adding layers, we could increase the alpha of the green, but it's already like there's still a lot of points, and the lines themselves will still overlap. So what we can try to do is swap the order in which we plot things, and then we add the jitter dots first, and then we add the geom for the box. And hopefully this will work. Okay, it's still not visually very appealing. You might choose a different color. But at least it gives us a kind of idea about where the points are, so we can see the data a bit more clearly. Another way to represent it is to use a geom violin. So you could try that as an exercise instead of box plot. This will, and you don't need jitter then because the violin plot shows the distribution in its shape. So if we had something like a bimodal distribution, we would not see it easily in the box representation. So something that might suggest there are two separate kind of clusters of values within our data. So yeah, this way we can see some species have a lot variation in weight compared to others. So this might be nice as part of exploratory data analysis step to check how are the values distributed, grouped by the value we're interested in. So another geom is for time series data. So this time, let's have yearly counts. First calculate for each genus, calculate the number of occurrences per year. Remember the count function we used before? It already does the grouping based on its arguments, so there's no need to explicitly call group by. We'll use our service complete data, and we can use a pipe here and count those. Genus should be a factor already. If it's not, you can turn it into a factor in the same way as we did before. So now we can use try to use geom_line to plot the counts. There is another notation as well. We can feed data into ggplot using a pipe. So plotting can become part of our pipeline. And we don't need to specify the data argument. And remember, count gives us a new column called n, so we can use that here. Okay, and now we can see some odd outcome because at this point we're kind of plotting all data as one set, so it kind of goes up and down. That's not what we want to do. So we need to fix that by adding a group at this stage. So it's one of the aesthetics values. Then data will be separated according to the group values into separate lines. Still not ideal because they all look dark. So we can change this actually to color, and color will automatically group things. Okay. So here we can see separate line for each of the values for genus feature. Later we'll see how to customize the plot to make the fonts larger and to change. So here we could write a count instead of the name of the column, and we could add the title as well. Any questions about geom lines for now? So the color needs to go into the aesthetics description. So S is short for aesthetics. Those are the values that define kind of the aesthetical components of the plot. So the axis, the tick marks, the color of the lines. In geoms are representations of our data items. So the violin code, I'll post it into the shared document as well. So we didn't really work on customizing that, but there are settings you can set inside the parentheses for each geom that will customize how those look like as well. So I encourage everyone to also have a look at this grammar of graphics description, then things might become more clear that it's kind of a layered approach to first making connection to the data set, then plotting the background, and in layers adding first the general kind of aesthetical components like axes and tick marks and labels, and later putting the data points in different ways. So we can both have, for example, lines and points on the same figure if we want a line plot where we can still see the data points as points on that line and things like that. And there are many more geoms, so we can't go into detail, but the book I mentioned yesterday, R for Data Science, has some other examples for histograms, let's say. And there are also examples in the ggplot package description, more in this tutorial style as vignettes. All right. So now we've got the colored lines, and we've seen how we can use the pipe operator. Let's have a look at faceting. This allows us to group plots as subplots within a single plot based on our grouping. So let me first copy this. We'll use the same data, but now instead of saying to the coloring here, we will first do the faceting. So the function is called facet wrap. Called wrap because once a subplot doesn't fit on a row of plots, it will be kind of dropped into the next row. And then we use this vars function that lets us specify feature on which to group or to group to subplot. So if we run that, so we'll still see lines, but now we can see that we got each line separately. Oops, sorry. Now we've got each line separately in each own little subplot. Depending on data set, sometimes you need to be careful because then these values might change, and you might need to set them manually to have this kind of uniform display where they're still comparable. Okay. Let's play around with this a little bit. So let's split out, let's split each line into 2 lines by sex. So if we want to female and male to have a separate line in each of the subplots. And there's a way to do this using the color. But first we need to, again, to subset data, to group data slightly differently. So we count, but we also need to add our new feature. So the grouping also happens not only by genus, but also by sex. This way, so my mistake. Service should be the initial data that comes into the pipeline, and the count happens on this line. To run this, we've got a new subset, and we can reuse much of the code, but be careful when copying and pasting things. So now we need to adjust the data that it's plotted. And then we add a color here back in. So I'll add the code for this to the shared doc. We're on line 308. So now we need to zoom in to actually see what's going on. Okay, we still got the NAs there. That's unfortunate. Let's filter them out. And we can do this as part of the pipeline. Let's hit this helps. Okay, there's still like empty plots there. So this suggests my dataset is not completely clean. So here this might be one data point still in that's not NA. And we can also see that now the default formatting for years kind of breaks down. If we have a smaller plot structure, then they overlap, and we can change that by rotating them, for example. But this is the idea. Now we've got also subgroupings within the plots based on the color specification. And this gets us quite a long way already for presenting complex data sets in this way.
Eugenie, are you using surveys complete for the latest sample?
Originally, yes. So we use surveys complete to subset that to get our group data. So if we look at the years, yearly counts, for example, the data looks like this. Based on n is created by the count call, and year and genus are those that we used to group by. And because count does group by implicitly, that's it uses and keeps those columns. So here, whatever we put in here will remain in our data set that we use for plotting.
Thanks.
And the only change for the new one is we add one more column. And now it appears here as well. And this NAs we would like to filter out. So we can also create some kind of a grid, a facet grid instead. Okay, so let me. So now I'm going to separate the data filtering into a separate pipeline back out. So I want to actually save that so I can reuse that later without the NA values. And now we can still plot that. And
Yeah.
then
Evgeny, I'm just
what
checking. Are you sorry? Zainab's posting something in the chat. Are you using surveys complete because your plot has 11 panels and it should only have 8? So I think you've.
Yeah, I guess my service complete might have had some NAs in it
But
that
your
still
yearly
survive.
count by sex at 452 is taking in surveys, not surveys complete.
All right, this might be
It's the code in line
my typo mistake.
452. Yeah,
Oh yeah, true.
452.
Good,
Just
good
use
catch.
the right data. Here you go.
Good catch. Good catch. That's what you get if you copy pasting too much. So now we've got that. Then we wouldn't need to filter, I guess. And then we should get a different view. So, but we still need the data, so we can specify it here. Yeah, so these types of errors kind of give away that something might be wrong with the data. So good catch there. So hopefully it now only presents the non-empty plots. So I think that looks more reasonable. Right. This should look like what you are getting. And now instead of facet wrap, we could try facet grid. So to have rows and columns based on features that we specify. It's not a geom, it's a facet. And we specify rows and columns as rows and calls, and we need this parse function around the name of the variable. for it to work properly. Let's see. Well, now because I was missing this bit, I also was missing that at the bottom. So this should now have two rows of plots. Zoom in. So we have now kind of separated them out in separate rows by one feature, which may or may not be useful, but this is something you can do. So this could be, for example, I don't know, like temperature and precipitation by month. Then it would be perhaps something that you would display in this way. Any questions about grids? So what you could try is now keep only the rows or only the columns and see what happens. So here, remove one of those and you will see how the display changes. So if I do this, for example, for columns, I keep the columns and remove the rows. Then everything will be, it will remain in one big row. And then things will be grouped back into one here. So we can fix the tick marks in a moment. So some code issue. It's quite difficult to read in the small chat window. I'd suggest to post it into the shared document instead, unless you can't get into the shared document. So this might be a typo, yeah. I'll copy the code I've got over as well. Okay, similarly, if you keep the rows and remove the columns, you will get a large column with all the lines on kind of like flipped figure of this one. So there are themes. Themes are kind of preset background aesthetics settings. So for example, for printing, we could consider theme BW for black and white. So white background does look better on when we're printing. So it might be slightly off-white, but still not as gray as the default setting. So, and it looks a bit more clear this way if you print it out. So, and there are many different themes. We're not going to go in depth. So there's, for example, a theme that will make your graphs look like the Economist figures that I think they're using ggplot for their figures. So to customize the labels, we can add another function here in between called labs as a shorthand for labels. And we can specify title. Something like that. And then we could also add X and Y type labels here. Instead of years, this will now appear as years of observations. And then instead of N, we want to use something more readable. For example, number of individuals. For this, let's see. We should have a title now and the new labels. It's still maybe a tiny font if we zoom in. But we can also change the position and the size of the fonts. So to change text size, we could add something like, so theme is responsible for the text size. And there are many different ways to tweak those. So we need to check the documentation of the theme to see what's supported. Let's say if we want to change text size to a large font, this way it looks larger. Now there's no space for the numbers, so we want to rotate them perhaps. Okay, this will let's see. So it's kind of the text orientation. We can set axis text on the x-axis. Okay, if we change the angle to 90, let's see what happens. history. So, okay, it's a bit better this way. You could kind of play around with angles and make them kind of slanted, and we can also adjust the justification. So now it's kind of adjusted to the right, so we can move it back to the tick mark with some other options. So there are plenty of such options, and need to dig through the docs to see them all. But the themes are fairly customizable, so you can also place some specific markers or arrows somewhere on the plot where you want to mark something and things like that. And this is an iterative process, so you change it slightly, you replot, you have a look. But then once your script is working, then if the data changes and you run it with a new data set, the plots will be reflecting that new data set, so there shouldn't be necessary to change then any of that parts of the script. So if the numbers are too large, could add a size as well. Now they got smaller, hopefully. So if we zoom in a bit more. Yeah. And to export a plot, you could do it through the GUI and save as image. Then a dialog will appear with where you can specify the name and where to put it, and width and height. So you can specify directories. So I would put it into the figures directory. And then if you click save, then it should appear in the figure directory. So I forgot to type in the file name, but you can specify the file name as well. All right, so yeah, let's spend some time plotting some other values. So as an exercise, you could select some other values and customize and plot them. There's a programmatic way to save a plot as well. So we could type something like, so for that we would need to save our plot. Save this GG object and then call a function called ggsave. Where we put in as arguments the file name, or the path rather. So actually we want it to be under figures. This is a path relative to the current working directory, the R working directory of which is set to our project here. And then we need to pass in the plot itself, the plot object. And then we can also specify, for instance, width and height. Okay, and we can also specify the units if we want to. But I'll stick with whatever default unit is for my graphics device. So the total ratio like this. And then it should appear here in the figures as a plot. So it's possible to save plots. So this way we can create a large number of plots automatically based on the data we got, and then we can inspect them manually to find like the most interesting ones. So resolution will depend on this width and height settings. You need to play around with those. They will also determine the font size. We can also use something like DPE value. That would be bad. 3 should be 300. Okay, you can see this is a percentage value, so the figure itself is much more high res now, but because of high resolution, then all the fonts gone tiny. So depending on what you need it for, like for a poster or for a paper, then you might need to have different sizes here. Okay, this is still a bit large in terms of font. So there's definitely some tweaking that needs to be done to have a nice outcome. But once you've found that setting, you can plot and you don't need to change that later on. So you can save, kind of document your way through that. So the plot object needs to exist and it needs to be created by assigning whatever the ggplot function returns. So that's important. Without it, it's not going to work. So there's also a package called Patchwork that can be used to kind of group plots together. But we unfortunately don't have much time left to go into details of that. So I'd rather experiment with customizing your own plots. So I think as an exercise, have a look around in the data, find an interesting value, an interesting feature you would like to plot, and then create a visualization. And if you can share it in the shared doc, we can then discuss it together. So hopefully this was enough of an overview to allow you to use it to create your own visualizations based on the analysis you could perform using the methods provided in the tidyverse package from the previous part of the workshop. So because this is all part of tidyverse, it kind of fits nicely together. So we've also seen how it's possible to combine an analysis and filtering pipeline together to kind of merge it with the visualization part. At some point, the connecting piece becomes the plus rather than the pipe operator. So once you're in the kind of ggplot world, you need to use plus to add new layers to a figure. Are there any questions about saving plots? So we might need to tweak all the settings to get exactly the ratio we want. But now we've got the tools to do that with the size settings and the height and width DPI settings. So there are also some other inputs that ggsave can take. So for instance, units, we can specify units as well. Or we can scale something. So there are also many other packages around based on top of ggplot for some specific ways to plot things. For instance, if you want to plot things geographically on a map, then there is a package that can do that on CRAN. So online there's the whole like ggplot gallery website that kind of showcases what can be done. I'm not familiar with slope graphs, but there's likely a package for that. I would be surprised if there isn't. Yeah, so it might be possible to do this with a line graph. Then you need to be careful about how you group things so that the correct kind of years fit together. All right, there are a few other things that can be customized within this theme. So we've seen axis text X. We can also customize the axis text Y element. So for instance, we could give it other size. And if we have a facet, the text inside the facet figure is called strip text. We can change its face, for example, to italic. And instead of saving, we can create the plot by calling the GG object itself. Unless I have a typo somewhere. So now you can see this changed to italic. All right. So that's roughly it for a brief overview of the ggplot package and its functionality. We've got a few minutes left. If you've got any questions, we can jump to any other bit that was unclear or explore one of your suggestions to plot some other feature of this dataset.
Yes, in case that there are no more questions, I think we can go early for lunch and come back according to the timetable. We start at 1:45. So let me check. Yeah, should be okay. So yeah, thanks Evgeny, and thanks everyone. And yes, I see you are 1:45 to learn a little bit more about SQL. Thanks.
Cheers. See you, everyone.